Our computer's on.
Computer is on, and here is the software on the desktop. Double click on that, data collection, and this is RSM stop flow. Press open. Now we're going to go to the calibration of the instrument. This instrument actually has a second monochromator, which is the excitation. It has a fluorescence capabilities, but we're not going to look at this for now. We're just going to look at the absorbance reaction.
So we left the...
Okay. So these are the two monochromators, excitation wavelength, which we're not going to concern ourselves with. This is the excitation.
This is the excitation.
And the RSM monochromator, which is the big monochromator that we looked at, the gratings. So here is the wavelength for the RSM monochromator, currently 600. And
it's currently set to 600 in software.
That's just where the wavelength is parked. If you look inside, it's kind of orange, and if I type some other number there, let's say 555, it's going to turn into something that is green. So this is just a very basic check to see that the monochromator actually moves, you get the light through, and everything looks okay.
So we're getting light.
We're getting light, the light changes, so the monochromator is fine, so we are ready to proceed. Now, a couple of words about the stop flow. The stop flow itself is actually, let me show you that. We have a separate unit here. We have a separate unit here that is actually pretty much the same stop flow that mounts on the top of the sample chamber. There's 6 screws, 3 on each side. There's screw holes bolted onto the sample chamber. Now the stop flow unit consists of 2 syringes, which are immersed in water bath. These are the plungers, and we have 2 syringes on the top, which are the filling syringes. So basically, we pour our chemicals, the solution of our chemicals, in these 2, and we fill this the sample syringes through the filling syringes. So when we're in fill position, these 2 knobs are turned into fill. We basically connect the filling syringe with the sample syringe. So this syringe goes to this.
So we put our sample in here, and then we fill it by pulling out these plungers.
That's correct. The sample is here. When I pull it, we suck it out of here, and it enters the sample syringe. When I push it, I return it back. So they're just connected.
So before our reaction, what do we want to do?
What you want to do, I'm not going to do this right now, but what we probably want to do is just fill them with water first, and make a couple of shots just to make sure the stop flow is moving and you get some reasonable signal. Now I know that is happening in this one, so I'm not going to do it. I'm just going to go with the test reaction. So I assume that's this is also checked by itself.
DCIP,
and ascorbic acid. So this is the DCIP, this is ascorbic acid. So now what is the principle of the stop flow? We have the 2 sample syringes, which, when they're full, let's say all the way here, are pushed by this device here, and of course, if you have the knobs into fill position, you just push the solutions all the way back into the filling syringe, which is not the actual experiment. The experiment is you turn these 2 knobs into flow. Now we cut the connection between the filling and the sample syringes, and now the 2 sample syringes are coming together through a mixer. The solution passes through the cell, which you saw down there. This is the cell underneath.
This is the sample cell?
This is the sample cell. This is where the mixing actually occurs a little bit before that. There's a special mixer, and then the mixture is passing through the sample cell and ending up into the stop syringe. So it's basically 2 syringes, mixer, sample cell, stop syringe, and that's the whole pathway of the solutions. And I'm just going to simulate a stop flow shot with my hands. We have these 2 knobs into flow position. There is a third knob here, which has 3 positions, which is set called flow, empty, and flush. I'm going to explain first what the flow is. The flow is the normal position for experiment when you, in this case, the solutions are proceeding to the stop syringe. So first I have to empty the stop syringe. If you want to empty it, you have to put it in empty. Press. So the solution here is going into the waste syringe. Click it back to flow, and now we are ready. So the stop flow shot is something like that. We push, the 2 syringes mix, and the mixture ends up in the stop syringe. The stop syringe hits a block here, and this is actually the physical limit. And when it hits the block, this is when the flow stops. At this exact point, the time 0 occurs. This is where your exponential curve or exponential whatever kinetic trace you look at is going to start. This is when the mixture starts aging already. So the mixture is the 2 solutions are mixed, and the flow is stopped, and we start measuring. So once the shot is delivered, we want, let's say we want to deliver a second one. We turn this into empty position.
Spell our solution into the waste syringe.
That's right. And click back to flow. Now there's a third position, and this third position is for cleaning the stop flow. What happens is if I put it in flush and I just push with my hand, the solutions from both syringes, they pass through the mixer and through the cell, but they don't end in the stop syringe, they end directly into the waste. So you want to do that when you, in the end of the day, when you clean the stop flow, we just fill it with water and flush it a couple of times, so that all the dirt ends up in the waste directly. Okay, so that was just a simulation by hand. If you want to actually do it with pressure, you have to turn on pressure of the gas tank. Now we have a gas tank with regulator. We have a 1/4-inch outer diameter tubing that goes to a firebox. Here we have a release valve that basically triggers the gas flow. There is a second line going from the firebox to the stop flow. You need to adjust your pressure somewhere between 80 and 100 psi. Currently I have it around 90. Over 100, it's already, you are running into risk of breaking the sample syringes. The shot is going to be too strong. There is no disadvantage really of having low pressure, except that your stop flow is going to start moving slower and slower when you start dropping the pressure, which in effect means that your dead time is going to increase. But there is no. Our recommendation is it's about 90 psi. So this is where I set it. This is about the maximum pressure that you can use safely.